Hi students, welcome back to the online lecture series of Basics of Computer Network. We are studying unit number 1, that is data communication and network models. Myself, Assistant Professor Mr. V.R. Vadekar from Matoshi College of Engineering and Research Center, Nasik. Now moving towards the end of this first unit, let's have a quick revision. In previous lecture, guys, we discussed about ISO and OSI model. ISO, it is an organization, and OSI, it is a model. There are 7 layers in OSI model: physical layer, data link layer, network layer, transport layer, session layer, presentation layer, application layer. And we have seen all the functions, duties of each layer. And we have seen the interaction between those layers. What is the concept of layer task? So let's have today's topic. Today we are going to see one of the most dominant protocol that is going to use in internet today, that is your TCP/IP, transmission control protocol and internet protocol. After that, we are going to see types of addressing. So let's start with our today's discussion. Now, TCP/IP protocol, it is a use in internet today. It is a hierarchical protocol which is made up of interactive modules, each of which, it is going to provide a specific functionality. Hierarchical means each upper layer, it is going to be supported by the services provided by these lower layers. And this is, a layered architecture, as like your OSI model. So you can see it that in TCP/IP model, there are 5 layers: physical layer, data link layer, network layer, transport layer, and together it is your application layer. In some books, it is shown by the 4 layers, that is host to network layer, IP layer, transport layer, and application layer. Whereas in some books, physical layer and data link, they are going to be separated. Just this is the difference, but the functions are same. Now you can see from this figure that the physical layer, as we know, it is responsible for carrying individual bits in a frame across the link. Although, this physical layer, it is the lowest layer in the TCP/IP protocol, but still, the communication between two devices in the physical layer, it is a logical. Because there is another layer which is below this physical layer, it is nothing but your transmission media. That could be your cable or it could be air. And we know the transmission medium, it doesn't carry bits, it is going to carry your data in the form of your electrical or optical signals. Although, the TCP/IP doesn't define any specific protocol for this physical and this data link layer, almost it is, same. They are going to support all the standard, any proprietary protocols. So there is no much, changes in those 2 layers. The third layer, it is called the IP layer. And as we know, the network layer is responsible for creating a connection between the source and the destination computer. Because the communication, at this layer, it is host to host, because several routers are present, between source and destination, and those routers are responsible for choosing the best route for each path. So the network layer in this internet, it is going to include this main protocol called the IP protocol, internet protocol, which is going to define the format of the packet, which is called a datagram. It is also going to define the structure of addresses. And IP, it is also responsible for, routing a packet from its source to destination. And remember, IP, it is a connection-less protocol, and it doesn't going to provide, no flow control, no error control, no congestion control services. So any of these services demanded by this application layer, can't rely on this IP layer. For this, it needs to rely on this transport layer. And this IP layer, it has, auxiliary protocols as like your, ICMP, that is your Internet Control Message Protocol, which helps IP to report some problems, when routing a packet. Next, it is your IGMP, that is Internet Group Management Protocol, which helps in, IP in multitasking purpose. DHCP, which helps IP to get the network layer address for a host. ARP, that is Address Resolution Protocol, which helps IP to find the link layer address of a host or a router. And reverse ARP. The next layer, it is called a transport layer. The logical connection at the transport layer is also end to end. This transport layer, it gets the data from this application layer. It makes it encapsulation, as we already seen, which is called a segment or user datagram. And then it is going to send it, through the imaginary connection. That is, if it is connection oriented, to the destination. So you can observe it over here, the different protocols are there. TCP, SCTP, UDP. So the main protocol, that is TCP, Transmission Control Protocol, it is a connection-oriented protocol. It means it is going to first establish logical connection between your transmitter, the transport layers at two hosts before transmitting the data. Then it also going to provide the flow control, error control mechanism. And the another protocol, it is your UDP, that is your user datagram protocol. And remember, TCP it is connection oriented, but the UDP it is a connection-less protocol. It means this protocol can transmit the user datagram. Now we call it a datagram instead of segment, without first creating this logical connection. Each packet it can follow the individual path, no dependency on them. So UDP it is a simple protocol. It doesn't provide flow control, error control, or congestion control as like your TCP. And SCTP, it is your stream control transmission protocol, which is designed to respond to new applications, that are emerging nowadays in multimedia. And last, it is your application layer. So you could find the difference in OSI model. These three layers were different, but in TCP IP model, session layer, presentation layer, application layer, these three layers together, this form a application layer. The functions of session, the presentation, the application layer, it is being involved in this your application layer. So you can find it different protocols are there as like your HTTP, that is your hypertext transfer protocol, which is used for accessing your World Wide Web. SMTP, that is your simple mail transfer protocol. which is used in your email. You do electronic mail, right now? So that use protocol SMTP. And when you are going to do the downloading, uploading, you're transferring files, for their FTP protocol it is working, that is a file transfer protocol. Then your telnet it is there. For accessing a site remotely, DNS it is there, that is a domain name system to find the network layer addresses of a computer. Then this SNMP, that is a simple network management protocol, which is used by the administrator to manage the internet, at global as well as local levels. So these are the few auxiliary protocols it has been added, and rest of the function it is same. And one difference, guys, the communication at the application layer in TCP/IP model, it is between two processes. To communicate, process sends a request to the other process and receive a response. So process to process communication, it is the duty of application layer. This is the difference. So as I already discussed, that is host to network layer, which includes physical and data link layer. No such specific protocols are there. Network layer, whereas we discussed these protocols. Transport layers, these are the auxiliary protocols. And application layer, which is going to combine the functions of these three layers. So 4 levels of addresses we use in TCP/IP protocols. That is your physical address, also called as MAC address or Ethernet address. Logical address, which is also called as IP address. Port address, and it is called a specific address. So what is the relationship of layers and addresses? It has been shown there that the physical addresses, it is given by this physical layer. Logical address given by network layer. Port address given by transport layer, and specific address is given by application layer. So now we would discuss the physical layer. So suppose a node, with address 10. See, this is a node with address 10. It wants to send a frame to a node with physical address 87. So they need to communicate with each other like this. But these two nodes are connected by a link. See, this is the bus topology. You can see it. These are the two nodes. This 28 and 53. Now the computer with physical address, see the data it is sent by the sender. And since it is a data link layer, it is going to do the encapsulation. In encapsulation, you can see the addresses of sender and receiver, it is there. So 87, it is the destination address. And 10, it is the address of your source address. Whereas trailer, it has been for error correction purpose. Now, when this data, when this frame, it is received by this intermediate node called station 28. Now it is going to match the 28 is not equal to 87. So it is not going to accept the data. So this frame, it has been sent to this station. Again in this station, it is going to match that 53 is not equal to destination address, that is your 87. It means it is not going to accept the data. So finally this data, it has been given to this receiver. And now it is going to match, yes, 87 is equal to this, 87 it matches. Then it comes to know this data, it is meant for this receiver only. And see how this physical address it looks. This is the physical address, which is a 6-byte hexadecimal digits. There are total 6 bytes, 1, 2, 3, 4, 5 and 6, and each byte unit is separated by this colon. So remember how we are going to represent physical address, MAC address. And you know that this digit, it is a hexadecimal digit that we are going to use for physical address. So total there are, how many hexadecimal digits are there? Total 12 hexadecimal digits are there. So this is the notation of your physical address. Next, logical address. Now you can see it over here. That suppose this station A, it is there. A, it is a logical address, and 10, it is nothing but your physical address, Ethernet address. So suppose it wants to send the data to receiver P, whose physical address is 95. So how the data, it is coming from this network layer to this data link layer. At the network layer, see, it has done the encapsulation A and P. What is A? It is a sender logical address. What is P? It is this receiver logical addresses. So this packet, it has been given to this data link layer. That is the second layer. So this layer again, it is going to do the encapsulation by adding the physical address and the logical address. But if you will find the difference, 10, it is a physical address of sender, but 20, it is not the, the physical address of the final receiver. Since data link layer is responsible for hop to hop or node to node delivery, so the 20, it is the destination address of this router, and particularly this port only, because there are 3 ports and each port, it has a different physical address. So now this data, it has transmitted, it is traveling through this LAN 1 and it is reached to this router 1, which has a physical address 20. Now it is going to match this 20, it is matches with this. But the destination address is P, but whose logical address is F, it is not matching. Then it needs to what? It needs to route the packet. So basically it is a router. So now it is going to send this data through this port. So you can see the difference. The logical address, that is P and A, they are not changing, they are same. Only the intermediate, only the physical addresses are going to change. Because when this router, it is going to send the data through this LAN 2 to this router 2, then for that router, who is the sender? Router 1, it is the sender. And from which port? Port number 99 it has been sent. So that's why the source address, it becomes 99 over here. But since it is the router 2 and it is going to reach to the port address of 33. So what would be the destination? The destination, it is B33. Getting? So this data that you can see, it has been reached to this port. Again, this router, it is going to find it. Through which port should I send? Should I send to 55 or 66? But from this table, it is going to calculate that final destination receiver, it is present at this link. So it is going to, transmit these data through this port. So you can see that logical address, again, it remained constant. What changed? It is a physical address. Now, since this data, it is received by the receiver. So what is the source address? Source address, it is your router 2, that is 66. So that's why we have written 66 over here. And now it is know that the end connection, it is the receiver. So it is, which has a physical address 95. So now it is going to put it 95. So when the data, it has been reached, it's received, that physical address, it is going to match. Then also it is going to check that logical address, it is also going to match. That is P, it is going to match with this P. It means this packet, this data, it is meant to this receiver only. So you can see the physical address will change from hop to hop, but the logical address usually remain the same. So that's why logical address is responsible for host to host end to end delivery. Now next it is your port address. As we know, the physical address change from hop to hop, but the logical address and the port address usually remain the same. So you can see it from the application layer, the data it is coming. This is your sender A and this is your receiver P. But on sender A, there are three processes are going on, A, B, C. And here are two processes, J and K. So the process A, it needs to want to send the data which should be received by the receiver, but the process is J. So this is the data sent by the application layer to this lower layer, transport layer. Now this transport layer, it is going to add the port address C, A and J. Means A, it is a source port address, and J, it is what? Destination port address. That is this. Now from the transport layer, it goes to network layer. So network layer, now it is going to do the encapsulation A and P, because P, it is the IP address of your destination, and A, it is the IP address of your source. Again from network layer, it goes to the data link layer. Again, it is going to add what? It is going to add the physical layer. Now this data, it is traveling to this internet, received by the receiver. Decapsulation it happens, and this data it has not given to process K, but it is given to process J, because it is going to match it, that this J is equal to this J. So in this manner, the port address usually remain same. And last address, which is called a specific address. Some applications have a user-friendly addresses that are designed for the specific addresses. Guys, your email address, or the web, that is www.something.com, youtube.com, google.com, that is your URL. These are the specific addresses. I want to send you mail. So it is going to design that particular domain. It is meant for Gmail, or it is meant for Sifi or any other else, Hotmail or Yahoo. But this section, this one, among that Gmail, sir, crores of, millions, billions of addresses are there, but they need to be specified. So this is going to make it a specific address. So that mail, it should be given to you only. It should be dropped into your mailbox only. So this is called your, the specific addresses. Now, whether this question, it is not in your syllabus, but still, why OSI not popular? Why there is a lack of OSI model success? There are many reasons, but I am going to discuss only few reasons. As like, guys, one interesting thing is that the OSI model, it has appeared after TCP IP model. TCP IP model, it came first. So first, when OSI model was completed, the TCP IP was fully in its place. Lot of time and money it has been spent on this TCP suite. So changing that one, it would be very, it is going to cost a lot. And second reason is that some layers in the OSI model were not fully defined. The services provided by the presentation and session layers were listed in the document, but actual protocols for these two layers were not fully defined, not fully described. And the third reason, it was that OSI was implemented by an organization in a different application. So, it is not going to show, any high level performance to switch from TCP IP to OSI model. So guys, today we have discussed about a TCP IP model. We have seen the analogy between OSI and TCP IP model. And What are the few auxiliary protocols it has been added to few layers? Then we have seen the types of addresses: MAC address, logical address, code address, specific address. And it is the end of unit number 1. So this is an assignment. So you need to note down this assignment and please solve it and submit to my this email address. So it's all about today's lecture. Thank you very much, and we would see you in next lecture.